The Seismic Review Committee gets involved in all the seismic retrofits for all buildings on the campus. The stadium was a particularly difficult one in the sense that it's a big facility, straddling a fault. And here we were using a technique that really hadn't been tried before. And so this was a unique opportunity to implement a new design. And so the collaboration between the review committee and the engineers was especially important here. The key points on which we assisted were in understanding where the fault was, understanding how to build a structure that can straddle the fault and survive fault movement without severe damage, and then also helping, especially with the press box, which is a very flexible structure, helping design ways in which that structure could be safe and dissipate the energy of the earthquake when the big one comes. Stadium uses this notion of sliding joints and bunkers that are able to move independently when the ground shakes. This is a new idea in design, but in fact, it's something that we've observed in past earthquakes accidentally. We've had bunker-like buildings that have straddled the fault, and we've seen how the fault actually moves through and around those buildings.
So we're standing in the upper part of the seating bowl, right near the stadium club level, and right above us is going to be the press box. It's to be a two-level press box with a press function and then a luxury suite above that. This press box will be supported on top of the core walls that you see here. These core walls go all the way to the foundation, but they're disconnected at every level. There's a joint which allows those cores to move. And at one level, we've connected those with large shock absorbers to the rest of the structure. So this entire thing can rock back and forth inside of the stadium. We're actually standing on top of one of these seismic rupture blocks. So this entire building is sitting on a 4-foot mat of concrete. Underneath that are layers of sand and high-density plastic. Those allow this entire piece of the building to shift without getting hung up on the ground. And in combination with the joints on the sides, this entire part of the stadium can just move as the ground moves. Right here, we've literally cut the old wall so that when this entire piece of the building moves, then instead of cracking up the old wall, it'll just cleanly shift by it.
Every seismic retrofit problem is a difficult problem. But the Memorial Stadium, this is going to be in the textbooks. It's unique. Nobody's tried this before, and the solution is a marvelous one that everyone's going to want to know about.